Hello, welcome to this video session. In this session we are going to solve one physics problem and this is related to force and kinetic energy. And this problem is from one of the past JEE mains question papers, but still it's actually a pretty simple problem and needs some understanding of what is force and what is kinetic energy. So let's take a look at the problem statement. We have a block of mass 2 kg that is free to move along the x-axis. It is at rest and from t equal to 0 onwards it is subjected to a time dependent force f of t in the x direction. The force f of t varies with time as shown in the figure. So this figure is provided as part of the problem. The kinetic energy of the block after 4.5 seconds is what? So let's discuss what is given and what we are required to find. There is a block of mass 2 kg. Okay, this block is of mass 2 kg and it is free to move along the x-axis, that is a straight line. Okay, but initially it is at rest and from time t equal to 0 onwards it is subjected to a time dependent force, that is a force acts on this block of mass and this force is not a uniform one but varies with time. So what does it mean? This force acts on this mass, that means it accelerates it from its state of rest and this block starts to move. So once it starts to move, still the force is continuously applied but with varying quantity. Okay, it's not the same amount of force that is applied initially, but it changes in value. It can be changed in its direction or it can be changed in its magnitude or it can be a change in both magnitude and direction. So the force, basically the force is continuously applied on this block of mass and the quantity of this force changes with the time. Okay, so that is what they mean by this time dependent force f of t. And this graph they have provided. So let's take a look at this graph. This horizontal axis shows the time, this is the time axis, and the vertical axis is the force axis, and this straight line shows the variation of force with time. So we can see when time is 0, the force applied is 4 Newton. Okay, so initially this force is 4 Newton, and as time proceeds the force actually linearly reduces. Okay, it's a straight line, so it's reducing linearly with time and eventually it reaches 0. So when time equal to 3 seconds, this line meets the x-axis, sorry, the time axis, so that is force becomes 0. And after t equal to 3 seconds, the force is still continuously applied on that block of mass but in the opposite direction. So why we are saying it is opposite direction is all these values of force are negative values. This part of this vertical axis is negative. So after 3.5 seconds, the value of this force is negative. So it's applied in the opposite direction. So basically what happens is initially this mass is at rest and the force of 4 Newton is applied, causing this block to move, and while it is still in moving, this force is continuously applied but in different quantities, not the same 4 Newton but of different magnitude or direction. Okay, and eventually this force is reducing in quantity and eventually it reaches 0, and after 3 seconds it starts to apply in the opposite direction. Okay, this is just the direction of force, not the direction of movement of this block, just the direction of force changes. Okay, it reverses. And given this data, we are required to find the kinetic energy at time t equal to 4.5 seconds. Okay, so it doesn't look like much complicated, right? Just a mass and a force acting on it, and we are asked to find the kinetic energy at a specific time. There is no gravity involved, no projectile motion involved, no collisions, nothing. So let us discuss how we are going to approach this problem, how we are going to find this kinetic energy. So let's start with kinetic energy. So for a mass m moving with the velocity v, the kinetic energy is given by mv square by 2. This we already know, right? So in this problem, the value of this mass is given as 2 kilogram, no issues. What about this velocity v? So since we need the kinetic energy at time t equal to 4.5 second, that means we need the velocity of this block when the time is 4.5 second. Okay, so if we know the velocity of this block of mass at time t equal to 4.5 second, then we can substitute this value here and we are going to get the kinetic energy which solves this problem. Okay, so how are we going to get this velocity? Okay, so the first thing we need to understand is only two data is given. One is the mass, another one is the time dependent force. So as we discussed earlier, this force causes this body to accelerate. That means it causes its velocity to change, right? Force acting on a body accelerates that body, and acceleration means what? Changes in its velocity. So that means this force continuously acting on this body causes its velocity to change continuously. Basically, velocity varies with time. That's the key takeaway from this problem. Okay, so what we need to do is we need to find this velocity as a function of t, right? So from the given problem statement we understand that this force is being continuously applied, which means the body is continuously accelerated, which in turn means this body's velocity continuously changes with the time. So that means we need to find velocity as a function of time, and if we find this, then here we can substitute t equal to 4.5 second. So this gives us the velocity at t equal to 4.5 second, which we can use here in mv square by 2, right? So our first goal is to find this velocity as a function of time. How are we going to find that? From this given force, dynamic force, that is time dependent force. So what is the relation between force and velocity? Now let's say a force F acts on a body of mass m, and this causes this body to accelerate, and let's denote that acceleration by A. Okay, force F acting on a body of mass m and causes it to accelerate, and that acceleration is denoted by A, and these three quantities are related by F equal to mass time acceleration, right? Okay, so now what is acceleration? It is nothing but the rate of change of velocity, that is the first derivative of velocity. Okay, force equal to mass time dv by dt, or in other words, Newton's second law states that force is nothing but the rate of change of momentum with respect to time. Okay, since mass is constant, we can take it out and we get mass into dv by dt. This is nothing but the acceleration. All right, so both are equivalent. Now you see you have this first derivative of velocity. Okay, so let's write it here. F equal to m into dv by dt, right? Now this is the relation between force and first derivative of velocity, but we need velocity, not its first derivative but the original function velocity. How can we get it? So if you know the first derivative of function, then you can get the original function by just integrating it, right? So let us say f of x is a function and f dash of x is its first derivative, right? That is df by dx. Okay, now if you integrate this one, integrate df of x by dx, you are going to get the original function f of x, right? So likewise here, if you integrate on both the sides with respect to t dv by dt, we are going to get on the right hand side, we are going to get velocity as a function of time. Okay, and on the left hand side you will get some function of time, right? And you can see this mass time velocity is nothing but the momentum. You understand it? So what we are doing is we are writing force equal to mass time acceleration, and we can see this force is related to the first derivative of velocity, but what we actually need is this velocity, not its first derivative. So what we are trying to do is we are trying to integrate on both the sides of the equation, and that way we are going to get velocity as a function of time, right? So for this we need force as a function of time, which is what given in the problem, but it is given in a graphical representation, not as a mathematical function. Correct? So if we get this f of t from this given graph, then we can integrate it and we can equate it to m into v of t, and this m is given in the problem as 2 kilogram. Okay, and we can move it to the left hand side, so that way we can get v of t. It's very simple actually. Okay, so now the key here is to find this f of t from this given graph. That is the key to solve this problem. So once you get this f of t from this given graph, okay, then you can just simply integrate it and equate to m times v of t. Move this m to left hand side and we are going to get v of t, and that means we can substitute t equal to 4.5, and straight away we can get this kinetic energy. Okay, so now the key here is to find this f of t from the given graph. How can we do that? Any ideas? And I would suggest you to pause this video for a few minutes and think about how you can get this function f of t, mathematical function f of t, from this given graph. It's actually pretty simple. Okay, let's continue. So this graph, you can see it is a straight line, right? And we have two distinct points on this line which is given, that is when time t equal to 0, force is 4 Newton. So this point is 0, 4. And here when time t equal to 3, force is 0, right? So that means this is 3, 0. So basically we have a straight line with two distinct points on that line. So that means we can use coordinate geometry to find the equation of a straight line given two distinct points x1, y1 and x2, y2 on that line. Okay, so which is nothing but y minus y1 by x minus x1 equal to y2 minus y1 by x2 minus x1, right? So from coordinate geometry we know that given two distinct points p1 and p2 on a straight line, we can use this 2-point form of a straight line equation. So let's use these points here. Okay, so in this case x is nothing but time and y is the force, right? So what is x1, y1? Let's take this one. X1, y1 is 0, 4. Okay, so now let's write this equation here. Okay, y minus y1 by x minus x1 equal to y2 minus y1 by x2 minus x1, where x1, y1 and x2, y2 are two distinct points on this straight line, right? So now in this case y-axis is the force and x-axis is the time. Okay, so what are these 2 points in this given line? 0, 4 and 3, 0. Okay, this is 0, 4 and this is 3, 0, and x is time, y is force. Okay, so let's substitute these values here. Y is the force, f of t, minus what is y1, 4, equal to by x is time, t minus x1 is 0, y2 minus y1, that is 0 minus 4, divided by x2 minus x1, that is 3 minus 0. Now what we are getting, f of t, you see we are going to get f of t as a function of t, minus 4 by t equal to minus 4 by 3, and you can move this t to the right hand side. That means f of t equal to minus 4 by 3 t, or this 4 to the right hand side, and we are getting f of t from the given graph, right? So what we have done is, we understand from the given graph that it is a straight line and we know two distinct points on this straight line, and from coordinate geometry we know the equation of a straight line given two distinct points on that line is y minus y1 by x minus x1 equal to, this actually is nothing but the slope of the straight line. Okay, so using this we found this force as a function of time. This is nothing but the mathematical representation of this graph. Okay, now here I want to point out one more thing. This is not the only method to find this force function. There are a couple of other methods. I'll just highlight one more method. So this is a straight line, right? And this straight line has a slope, right? And you know that the first derivative of this line is the slope. What is the slope? This y2 minus y1 by x2 minus 1. Or in other words, the change in force with respect to time, right? So over a time of 3 seconds, okay, the force drops from 4 Newton to 0 Newton. That is, over a time period of 3 seconds, the force drops from 4 Newton to 0 Newton. So final force is 0, initial force is 4, and final time is 3, initial time is 0. This is what we got using this. You can see here 0 minus 4 by 3 minus 0. The same thing, 0 minus 4 by 3 minus 0. Right? The change in force with respect to time. This is minus 4 by 3. And this is F, this is T. Okay? So we can write dF by dt equal to minus 4 by 3. And if you integrate on both sides, what happens is you get minus 4 by 3t plus some constant of integration, because this is an indefinite integral. On the left hand side you are going to get the original function f of t, because you are integrating the first derivative of force and you are going to get the force function itself. Okay, how are you going to find this c? Using one of these two conditions. For example, you can substitute this one here. So that is, force at time t equal to 0 is 4 Newton. That is f of 0 equal to 4, right? So minus 4 by 3 times 0 plus c equal to 4. Okay, that means this term vanishes, it's 0. We get c equal to 4. So what happens is f of t equal to minus 4 by 3t plus c equal to 4, right? 4. This is what we got here using coordinate geometry, 2-point form of a straight line equation, right? I just want to highlight this another approach to find this function. Okay, now back to the problem. So we got this function, force function, and what was our plan? We use this approach to integrate it. So let's write it here. F of t equal to mass time dv by dt. This velocity is a function of time, right? Now let's substitute this here. So minus 4 by 3t plus 4 equal to, mass is 2 kilogram, right? So 2 into dv by dt, and then we integrate on both the sides. Okay, let's write dt dt. So what happens? This is minus 4 by 3 t square by 2 plus 4t plus some constant of integration, we don't know, equal to 2 into velocity, because we are integrating the first derivative. So we are going to get the original function. Now let's rearrange this equation and bring this v of t to the left hand side. So equal to, this one gets cancelled, minus 2 by 3 t square plus 4t plus c, and we have to move this 2 also, right? So okay, let's do it in the second step. V of t equal to minus t square by 3, we are moving this 2 to the right hand side, so this cancels, plus 2t plus c by 2, and we don't know the value of c yet, so let's keep it as c itself. So this is the velocity as a function of time, right? So from the given graph we found force as a function of time, and we integrated that function and we got v of t, velocity as a function of time. Now the only thing that remains is this constant. How are we going to find this? In the problem they have given the initial velocity is 0. That means velocity at time t equal to 0 is 0, right? So we can use this boundary condition here. So what it means is v of 0 equal to 0. This implies, let's substitute 0 here. So what happens, this is 0, this is 0, all that remains is c equal to 0, right? So basically this term vanishes from this equation. So all that remains is v of t equal to minus t square by 3 plus 2t. This is our final velocity function. Velocity is a function of time. Okay, so now it's almost solved. We are almost there. All that remains is to substitute t equal to 4.5 in this function, and we are going to get this velocity, and thereby we are going to get this kinetic energy, right? So let's do that. We have 4.5 equal to minus 4.5 square by 3 plus 2 into 4.5, 9. And if you compute this, then you will be getting this value 2.25 meter per second, okay, unit of velocity. So velocity of this block of mass that is subjected to a time dependent force at time t equal to 4.5 is 2.25 meter per second. Let's go to the kinetic energy, equal to mv square by 2. Mass is 2 kilogram, right? So 2 cancels out. All that remains is v square, that is 2.25 square, and unit is joule, okay? And this value is 5.0625. This you can compute using a calculator. So kinetic energy of this block of mass at t equal to 4.5 second is this value, 5.0625 joule, okay? So now we have solved this problem. Now let's take a quick recap of what we actually did. So we know kinetic energy is given by mv square by 2 and mass is given, but we don't know the velocity of this block at t equal to 4.5 seconds, so we needed to find this one. Now from the given problem we understood that this force is being continuously applied on this block of mass, which means it is continuously accelerating this block of mass, which in turn means this block of mass has a varying velocity. The velocity is varying with respect to time. So thereby we wanted to find this function velocity, okay? Velocity is a function of time, and once we get this function, then in this we can substitute t equal to 4.5 and we can use that value here in the mv square by 2. So then we found the relation between force and velocity. We wanted to find the link between force and velocity, so we started with force equal to mass time acceleration, which is nothing but the first derivative of velocity, and we knew that if we integrate this equation, we can get the original function v of t. So our approach was to find f as a function of t, that is force as a function of t, from the given graph. And in this given graph we know this is a straight line and there are two distinct points given on the straight line. So therefore we use this 2-point form of a straight line equation from coordinate geometry, so which gives us this force as a function of time, okay? And then we used it to integrate and we got this velocity as a function of time, and using the initial condition, that is the initial velocity is 0, we found the value of this constant c, which is nothing but 0. So we got the final velocity as a function of time, and in this one we substituted t equal to 4.5 and we were able to get the velocity and thereby the kinetic energy. That's all. So now that we have solved this problem, let's do just one quick thing before we conclude. Can we try to find the time at which this block comes to rest? I mean, at which the velocity of this block reaches 0. The block becomes 0. Can we try this one? So initially it was at rest and the force was applied and the force was continuously applied, and eventually the force became 0, and then it still continued to apply but in the opposite direction. Basically that means somebody is pushing this object with varying magnitude, and eventually they stop that force and they start to pull that object, right? So we are going to find at which time this object comes to rest. That means v of t equal to 0 for what value of time, right? So take this equation, minus 2 square by 3 plus 2t equal to 0. This implies t square by 3 equals to 2t. So this goes here and becomes 6t, right? So this is actually a quadratic equation, t square minus 6t equal to 0, right? So this is a quadratic equation. Okay, let's write it here. T square minus 6t equals 0. Okay, that means t of t minus 6 equal to 0. Now there are two solutions to this equation. One is either t equal to 0 or t equal to 6. Okay, when t equal to 0, the entire equation becomes 0, the left hand side becomes 0 and equates to the right hand side. Likewise, when t equal to 6, this factor becomes 0, 6 minus 6 0, so this entire left hand side becomes 0 and equates to the right hand side. So there are two solutions. That means when time is 0, it is at rest. That's what given in the problem itself, right? Its initial velocity is 0, it is at rest. And then the another time when it becomes rest is t equal to 6 seconds. Okay, so at these 2 points of time it is at rest. And here what it means is, as we mentioned here, it was this force, right? It is applied and it eventually reaches 0 and then it is applied in the reverse direction. So that means the object has to at some point of time stop and then start moving the opposite direction. So that point of time is t equal to 6 seconds. Okay, now one thing I want to mention here, this force as a function of time we found, right? This one, strictly speaking, mathematically speaking, this is valid only for this interval of time, that is 0 to 4.5 seconds. Actually this is for t greater than equal to 0 and t less than or equal to 4.5, because we are only using the information provided in this graph. We are not assuming that this line is proceeding further. Okay, so without that assumption we got this function, and this function is good enough to solve the problem and get the kinetic energy. But in this scenario for t equal to 6, so that means we have to assume the straight line proceeds further. Okay, only then this answer will be valid. Okay, that's something we need to keep in mind. Okay, I think with this we can conclude this session, and I hope this session helped you in your learning, and we will meet again in another video. Thank you. Bye.